Mr. Andy Parker is a research fellow, Institute for Advanced Sustainability Study, Germany, and project director of SRM GI. He has been working on solar radiation management for a long time. Please welcome Mr. Andy Parker to the podium.
Well, thank you, Professor Dasgupta. First of all, I just wanted to add my voice as sincere thanks to the University of the West Indies and the Caribbean Academy of Sciences, the Jamaica chapter, for putting this meeting on. It was, I think, 3 years ago that Tara and I first spoke to each other about the possibility of the meeting, and then only 8 weeks ago that we finally decided we were going to go ahead and put this on, and it's been achieved at a breakneck pace, but thank you so much for hosting this. It's been a tremendous pleasure. Also, thank you to Minister Chang for your attendance. It's a real honour for me to address you and the other distinguished guests who are here today, so thank you all for coming. As Professor Dasgupta mentioned, I work at the Institute for Advanced Sustainability Studies in Potsdam in Germany. I research the governance of solar geoengineering. I work on the politics side, not on the science side. And I also am project director for the SRM Governance Initiative, which is one of the partners for today's meeting. And that's an international NGO-driven initiative that seeks to expand the conversation around SRM geoengineering, particularly to developing countries, and particularly regarding what we think is the greatest current concern. That's the governance of research into SRM. Who has a voice? Who gets to do it? What direction does it go in? But first of all, let me say a few points about SRM, so make sure we're all on the same page. This is a theoretical proposal for cooling the planet by blocking out a small percentage of inbound sunlight. Now, I'm sure you're all thinking that sounds like science fiction. It's being taken very seriously by some very serious scientists, by a number of august institutions who are concerned about the pace of action on climate change, and people are wondering whether solar radiation management might be able to reduce some of the climate risks we're already committed to. I want to be clear, I'll say it now and I'll repeat it through the day. SRM cannot be an alternative to reducing greenhouse gas emissions, but we are here to wonder about whether it might be able to make a contribution to reducing climate risk and how we govern research into it. To set the scene, it's not possible, I believe, to have a really sensible conversation about SRM without first talking about the climate context in which we find ourselves. So I'll set the scene briefly. The CO2 that we're releasing right now when we breathe out, that we release when we burn coal and oil and so on, that, at least a certain portion of it, will stay in the atmosphere for decades, and about a third for centuries and even millennia. Even if we cut global emissions of CO2 to zero tomorrow, then the planet would keep warming up for decades because there's inertia in the system. There's CO2 that has already been released. And despite promising signs from the Paris Agreement, we're not looking likely to cut emissions to zero at any date soon. And so people have been wondering, what are our options for dealing with the climate risk from the CO2 that's already been emitted to the atmosphere? And some people have said that we need to research solar radiation management, SRM geoengineering. So, what is SRM? Well, just over 25 years ago, it was the 15th of June 1991, Mount Pinatubo, which was a large volcano, erupted in the Philippines. And Pinatubo blasted millions of tons of sulfate particles, tiny reflective aerosol particles, into the upper atmosphere, the stratosphere. And for the next year or two, they circled the planet on the stratospheric winds. They blocked out a very small amount of inbound solar energy, inbound sunlight, and the planet cooled down. You can see it in the temperature record for 1992. It was visibly cooler because of the eruption of Pinatubo. So scientists, dismayed, concerned at the pace of emissions reductions, started to wonder, well, is this effect, this cooling effect from volcanoes, is that something that we could replicate deliberately? Could we do this deliberately to cool the planet? And the answer is, well, we very possibly could. It's been proposed that jets could fly sulfates up to the stratosphere, release them, perhaps a balloon and hose array, the balloon up in the stratosphere, the hose to pump up the sulfates. And it's been calculated that a 2% reduction in inbound solar energy would mask the warming from a doubling of CO2 in the atmosphere. So this is a very potent technology. It's also potentially concerningly cheap. as a technology. Concerningly, I say, because it's likely to cost, at least if calculations are to be believed, only a few $1 billion per year, perhaps tens of billions of dollars per year to deploy this. So not cheap in some respects, but extremely cheap when compared to, say, the projected costs of climate change. I read a report on the way over here that said by the year 2050, Jamaica's tourist industry alone could be losing between $1 and $8 billion US dollars per year to the effects of climate change, from sea level rise, from storm surges. So that puts the concerningly cheap cost of solar geoengineering into some context. I say it's concerning because, at least in theory, a single country could go out there and cool the entire planet down on everyone else's behalf. So, as I'm sure you're thinking, the question is not just, could we do SRM? The question that concerns geoengineering researchers like me, like Juan over there, like Holly, who you'll be hearing from later. No, the question is, should we do this? What would the impacts be? Who gets to decide? And so on. The answer to that is no one knows at the moment. This is only in the early stages of research. And research is in its infancy. There's been next to no field studies done. Most of the research is done in the library, is done on computer models, done on supercomputers, like the one that the university has taken charge of this morning. But I'm going to now give you what I consider to be the 5 most important messages on solar geoengineering that have been learned from about the last decade of very serious research. 5 messages are as follows. If you take nothing else away from the day, take this. 1. I'll say it again. SRM cannot be an alternative to reducing greenhouse gas emissions. It only imperfectly masks the warming from greenhouse gases in the lower atmosphere by blocking out sunlight in the upper atmosphere. It could cause changes to weather patterns, for instance. So it will not take you back to the climate that you once had before. It would do nothing about ocean acidification because it does nothing about the CO2 in the lower atmosphere. So it's not an alternative to emissions reductions. But as Professor Dasgupta noted in his opening address, if it could be made to work, SRM would be the only known way to cool the planet at short order, or to stop the warming at short order, because there's inertia in the climate system. The evidence that we have from the last 10 years of modelling, last 10 years of climate models, is that SRM, if it were used globally, would produce a world that was much more livable than a world of unmitigated climate change. So the evidence we have, it says that SRM could be quite good for reducing climate risk. But, and this is absolutely crucial, but that evidence is really limited. It's only preliminary computer modelling that's been done. The uncertainties are very large. The risks are very large. So SRM could prove much worse than the climate change that it seeks to address. We don't know a lot about it yet. Finally, as I'm sure has occurred to you intuitively, the science is only one part of this. Many experts believe that the political, the social dimensions, that's what's going to dictate whether this is a useful technology or something that's a dangerous distraction. So how would it be possible to get global agreement on where to set the global thermostat? Russia might want it a degree or two warmer. Jamaica in July might want it a degree or two cooler. How would you get agreement between different interests around the planet? How is it possible to make equitable and democratic decisions over such a global technology? How can you ensure everyone's voice is heard? And how can we make sure that the idea of geoengineering does not distract politicians and publics from the crucial task of cutting emissions? These are all very important questions I want to hear from you about as the day goes on. So we think the challenge is going to be about governing research. Who makes decisions? How? In what direction does this go in? Is this cooperative? Are the results transparent? That's primarily what we want to talk about today, because that's what we think is the next great challenge. So to finish, I'll just say a couple of words about SRMGI, the project I work on, the SRM Governance Initiative. Our mission is to expand discussion to developing countries, just to talk about SRM. We want to hear what you think about it, because there is a discrepancy between where the research and discussion are currently happening, which is typically North America, Europe, in Japan somewhat, and where the effects of SRM would be most keenly felt. That's in equatorial regions, in developing countries, in places where the population is most susceptible to climate change. We think a laissez-faire approach to the development of climate engineering would result in it being developed in developed countries, whereas the effects will be felt most keenly in developing countries. And we think people from developing countries should be part of this conversation. Therefore, we run a series of meetings in India, China, Pakistan, Senegal, South Africa, Ethiopia, where we've done very similar things as we're going to do today. Just start this discussion, find out what people think, how they might be affected by the issue. And so, yeah, thanks to a generous grant from the Open Philanthropy Project, we're expanding our work over the next year. This is the first in our series of meetings we're going to be running over the next year. But as I said, we want to expand this discussion. We are neutral on the issue of SRM. So when the meeting finishes today, when you all go home, we don't care whether you leave here thinking, that's the worst idea I ever heard, or whether you leave here thinking, well, there's potential in that. That might be something that can help us reduce climate risk. We just think that the conversation needs to expand, and we're here to hear what you think. So this morning's discussions are going to be mainly presentations. After lunch, we're going to be having group activities where it turns over to you, and we want you to tell us what you think will happen next with research governance. With that, I thank you. I thank you, Professor Dasgupta, and I'll hand you over. Thank you.